Okay, good day. So this is our lecture for the subject P6. Under this subject, the most frequent topics that are coming out for in our board exam is we have the dynamics. So basically, we have dynamics also under mechanics. So when it comes to dynamics, we have two main branches. First, we have the kinematics. And the other is the kinetics. If we say kinematics, we are just dealing with the acceleration, displacement, velocity, and time of the motion. So unlike for kinetics, we are considering everything including the forces or force that may affect the motion or that may cause the motion. So we have a simple case of dynamics or the objects in motion. That is, if we have a constant velocity. So if the velocity is constant, basically the acceleration is equal to 0. That makes the equation of the velocity simply equal to the distance. We're using S for distance over time. Just like this, our example. This is a board exam for civil engineering way back November 2010. So let's try this one. Alright, so let's have this example. This is a pass board, CE November 2010. So a man fires a target with a bullet's velocity of 900 meters per second. After 2.5 seconds, he hears the sound of the bullet that strikes the target. Assuming sound has a constant velocity of 350 meters per second, how far is the target from the man? So as you can see, we have a time given. We have time is equal to 2.5 seconds. So take note that we will be having two time intervals. First time interval, that is we have the time for the bullet to travel from the man to the target. Then second time interval, that is for the sound to travel from the target to the man. So we having an equation here for the time. That is, we have time number 1, that is the time for the bullet to travel, plus time number 2, that is for the sound, equal to 2.5 seconds. So if you are to consider the bullet, okay, basically velocity is equal to distance over time. For the bullet, we have 900 is equal to the distance over, let's say, time number 1. So we're having an equation of the equivalent of time number 1, let's say time number 1 is equal to the distance divided by 900 meters per second. That is for the bullet. Then for the sound, we have the velocity of 350 meters per second is equal to, take note, we are dealing with the same distance, divided by time number 2. And I will be having an equivalent of time number 2 equal to the distance S, that is divided by 350. Then we are just to substitute the equivalent of time number 1 and time number 2 on our initial equation. So we have, what is the equivalent of time number 1? That is the distance divided by 900 meters per second. Plus, time number 2, we have, that is, T sub 2 is equal to the distance, this is divided by 350, equal to a total time of 2.5. So again, I'll be using Canon F-789 SGA so that we can use the ship solve or ship calc. So we have a distance equal to 630 meters. Okay, that is our answer, and we have letter D. Okay, so majority of the cases on our board exam when it comes to dynamics, we have the case of constant acceleration. So if we are to consider the application from differential calculus, for example, a particle moves from one point to the other. So let's say this is differential distance with respect to the things in time. So basically velocity is the change in position divided by the change in time. That is our equation for velocity. While for the acceleration is differential velocity with respect to differential time. That is the change in velocity with respect to time. So for example, how do we derive the equations from this two? For example, the first one. We have this is acceleration is equal to the change in velocity over the change in time. So we have the change in velocity is equal to acceleration differential time. Considering constant acceleration, we are to integrate both sides of the equation. This is from initial velocity to the final velocity. This is from 0 up to time t. What is the integral of dv? That is b. To be integrated from b1 to b2. So that is b to be integrated from b1 to b2 is equal to the acceleration. Integral of dt is t to be evaluated from 0 to t. Or basically we have this equation, d sub 2 minus lower limit, d sub 1 is equal to acceleration times that time. Never mind the lower limit since I put 0. So we have the first equation as the final velocity transpose is equal to the initial velocity plus the acceleration times time. So this is one of the key equations. Under constant acceleration. How about this one? We have velocity is equal to differential distance over differential time. Differential distance is equal to velocity divided by differential time. So considering that this velocity is the final velocity, so we have ds is equal to, let's say this is the final velocity. Equivalent to final velocity, we have v1 plus the acceleration times time multiplied by differential time. So we integrate, this is from 0 to s, a constant v1, constant acceleration, variable is time. Integrate from 0 to time. So we have this is s to be evaluated from 0 to s equal to v1, integral of dt is t, v1t, plus we have the acceleration, integral of t dt is time squared over 2. So we have, since the lower limit is 0, we have the displacement or distance is equal to initial velocity times time plus 1/2 the acceleration times the time squared. So another key equation for constant acceleration. Let us use the combination of the two. As you can see, we have a common differential time. So what is the equivalent of the differential time? dt. From the first one, that is differential distance over the velocity equal to, what is the equivalent of dt from the equation of the acceleration? That is dv, differential velocity over the acceleration. So we use these terms. So let us use vdv cross multiplication is equal to acceleration ds. Then we integrate both sides of the equation. This is from initial velocity to final velocity. This is from 0 to s. So the integral of b dv is equal to, we have b squared over 2 to be evaluated from b1 to b2 equal to a ds, this is 0, as. So let us now evaluate. We have now this upper limit b sub 2 squared minus b sub 1 squared divided by 2 is equal to as. Then if you are to simplify, this is the same as the final velocity squared equal to the initial velocity squared plus twice acceleration times distance. So we have the third key equation for constant acceleration. We can apply this equation into rotational motion, projectile, vertical motion, etc. So let's have an example. Our next example. So at a certain instant, two cars X and Y are 2,000 feet apart. At this instant, X has a speed of 15 miles per hour and accelerating at 3 feet per second squared, while Y is moving towards X at a speed of 30 miles per hour and accelerating at 2 feet per second squared. So question, when will the two cars meet? So first, let us be consistent when it comes to our units. So we are to convert the miles per hour. For example, we have the initial velocity of car X is 15 miles per hour. This is multiplied by, we have 1 mile is equal to 5,280 feet. This is multiplied by 1 hour is to 3,600 seconds. So you have the velocity of car X, initial velocity, and we have 22. This is 22 feet per second. Well, the initial velocity of car Y, let's say this is dy1 equal to, that is 1530, so it means all you have to do is multiplied by 2. This is 44 feet per second. So you have the initial velocities. So let us assume a meeting point. Let's say this is the meeting point. This is the distance to be covered by car X, the distance to be covered by car Y. So if we are to set our equation when it comes to the distances, S of X plus S of Y is basically equal to the 2,000 feet. So what is the most suitable equation from our three main equations under constant acceleration? The first one, final velocity squared is equal to initial velocity squared plus 2as. Second, final velocity is equal to initial velocity plus acceleration times time. And the third one, S is equal to initial velocity time plus 1/2 acceleration time squared. Okay, all you have to do is observe the given and observe these three equations to determine what is the most suitable equation or the best equation to solve the problem. As you can see, we have involved distances, we have initial velocities, we have acceleration, we are looking for time. So the best equation is the third one. It should be the best equation for this problem. Okay, so let's say we have for distance x, the distance x is equal to, what's the initial velocity of car x? We have 22 times the time plus 1/2. The acceleration of car x is 3 times the time squared. So that is the distance for car x. Distance for car y, we'll be having initial velocity, that is equal to 44. Okay, this is multiplied by time plus 1/2. Acceleration of car y is 2 times the time squared. Take note that these two cars are moving at the same time. Therefore, we are solving for just one value of time. So from this equation, we may have or we may express that distance y is equal to 2,000 minus distance x. What is the equivalent of sy? And we have that is 44 times the time equal to 44 times the time for car y, plus 1/2 of acceleration 2, that is the time squared, is equal to 2,000 minus what is equivalent of the distance covered by car x. We have 22 times the time plus 1/2 acceleration 3 the time squared. As you can see, for this equation, we have a single unknown of t. So let's compute for that value. And so we have a time up. This is 18.013 seconds. So let us check on our choices. Our 18.013, our closest value, we have letter B, 18 seconds. Our next example, this is for vertical motion. So from our initial equations a while ago, b sub squared is equal to b sub 1 squared plus 2as. We are just to rename some of the terms. That is the same as b sub squared is equal to b sub 1 squared plus 2g. That is, since we are dealing with vertical motions, we are using a constant acceleration, that is the acceleration due to gravity. Then, in some references, they're using h for the vertical distance or sometimes y. We are just using h. So we have b sub 2 is equal to b sub 1 plus acceleration times time. Equivalent here, we have b sub 2 equal to b sub 1 plus acceleration due to gravity times the time. Then s equal to b1t plus the 1/2 at squared. Here we are using vertical distance height h equal to initial velocity time plus 1/2 gt squared. So this is the equivalent, just the appearance of the equation if we are dealing with vertical motion. So our sign convention, if the motion is upward, I'll be assuming negative g, and if the motion is downward, I'll be assuming g is positive. Take note that motion is slowing down if the motion is upward. If it is going down, the velocity is increasing. So that's why we have a positive convention. So let's have this example. An object is dropped from a cliff into the sea. The impact of the object on the sea surface was heard 5 seconds later, after it was dropped. The velocity of sound is equal to 1,120 feet per second. Required, how high is the cliff? So again, we'll be having two sign conventions here. Time number 1, that is for the object to fall and reach the surface of the ocean. Then our time number 2, that is for the sound to travel. Okay? So we'll be having time number 1 plus time number 2, a total of 5 seconds. Time number 1 for the object to fall, time number 2 for the sound to travel upward. So what is the most suitable equation for this case? So again, if from the term, an object is dropped, if we have that term, or an object is just released, we are assuming that the initial velocity is 0. The term for this is this is the free fall. Okay, for a free fall, initial velocity is always equal to 0. So we can use the third one, since we are looking for h and time is given. Okay? So for the equation, h is equal to initial velocity time plus 1/2 gt squared. Okay, so let's say for the object, to fall, we have h is equal to initial velocity is 0 plus 1/2. Okay, this is in English unit. We have 32 feet per second. That is, we have 32.2 times the time squared. This is our first equation, or we can simplify this one. It is the same as h is equal to 32.2 over 2 is 16.1 the time squared. And that is for the object. What about the sound? Is the sound affected by the gravity? Okay? This is for the sound. Is the sound affected by gravity? Basically, no. The sound is not affected by gravity, which means our equation is basically velocity of sound equal to the height divided by time. Okay. Since it is not affected by the acceleration due to gravity, we have the velocity is equal to 1,120 equal to the height. This is divided by, let's say, time number 1, that is for the object to fall, T1. Time number 2 for the sound to travel, let's say this is T sub at time number 2. So this is 1,120 is equal to the height divided by time number 2. So we have another equation, H is equal to 1,120 time number 2. So we have two equations of height. We have the equations of height. Let us equate them. So what is the height in terms of the free-falling object? That is 16.1 times squared. Equal to, we have 1,120 time, this is time number 1, time number 2. So we have the total time is equal to 5 seconds. We have time number 2 is the same as 5 minus time number 1. So this is 16.1 time number 1 squared is equal to 1,120. Time number 2 is 5 minus T1. So let's compute for our time number 1. So time number 1 is equal to 685 seconds. Can we now determine the height? I will make use any of the equation. I'll be using the first one. This says the height is equal to 16.1 multiplied by time number 1. We have 4.685. This is squared. So we have the height of the cliff. It's equal to 353. It's equal to 353.383 feet. So this will be our answer. Let us check on our choices. My rounded value, we have letter B, 353 feet. This is our next example for vertical motion. So a man standing at a window, so that is a window which is 5 meters tall, watches a falling stone pass by the window. So we are assuming that a stone passes from the upper edge to the lower edge of the window for a period of 0.3 seconds. So the height of the window is 5 meters. From how high above the top of the window was the stone released? So we are looking for H number 1. That is from the point of release to the upper edge of the window. So that is our unknown. So how do we compute for that? So again, this is an example of free fall. We assume the initial velocity to be 0. So let us consider this distance from the point of release to the upper edge of the window. We have to use the third equation. H is equal to initial velocity time plus 1/2 acceleration time squared. So the time for this stone to travel from the initial point to the upper edge of the window is time number 1. So initial velocity is 0. We have H1 is equal to 0 plus 1/2. This is metric. We have 9.81 meters per second. Time number 1 squared. So that is the equivalent of H1. We have H1 is equal to 1/2 of 9.81 time number 1 squared. So that is from the point of release to the upper edge of the window. So what is next? Let us use the given, the 5 meters and the 0.3 second. So we are considering the total distance. This is our total distance H. And our total time, of course, this will be our total time. So we are just to use this equation. We have the total distance is equal to initial velocity total time plus 1/2 g total time squared. What is the equivalent of the total distance? That is basically h1 plus 5 meters. So that is h sub 1 plus 5 meters equal to initial velocity is 0 plus 1/2 of 9.81. What is the equivalent of the total time? So our total time is T1 plus T2, the 0.3 second. That is T sub 1 plus 0.3 squared. Okay? Do we have the equivalent of H1? The equivalent of H1 is, we have 1/2 of 9.81. That is time number 1 squared. That is the equivalent of H1. Okay, plus, we have plus 5 equal to, this is 0, 1/2 of 9.81. We have T sub 1 plus 0.3 quantity squared. So we can solve for time number 1. That is from the point of release to the upper edge of the window. So we have a total time of 1.549 seconds. So that will be the time from the point of release to the upper edge of the window. How to compute for H1? So we have H1 is equal to, from this equation, we have 1/2 of 9.81. The computed time number 1 is 1.549. This is quality or value squared. We have H1. So we have 1.549 squared times 9.81. This is divided by 1.549 squared. This is times 9.81 divided by 2. So we have 11. This is now 11.769 meters. So that will be our answer. So in our choices, we have letter B, that is 11.77 meters. So we proceed to our next topic. This is the relative velocity. So when it comes to problem solving, some application is the movement of a boat on a river or stream. That is the same as the movement of an airplane on air. So the concept of relative velocity, if we have the same direction of movement, we assume the relative velocity to be the summation of the velocities. So we have V1, V2. But for example, we have V1 is to the right and V sub 2 is to the left. Your relative velocity will be the difference of the two. So let's have an example. So according to problem number 5, it takes a boat 3 times to travel upstream, that is against a river current. Then the time it takes to travel downstream, if the speed of the boat is 40 miles per hour, what is the speed of the current? So we are talking about the same distance here. If the boat is moving against the current, so let's say the boat is to the left and the current is to the right, the time will be 3 times the usual time if the boat will travel along with the current. So how to compute for, we are looking for the velocity of the current. Since the velocity of the boat, we have 40 miles per hour. Right, so let us solve. What will be our equation? For the first case, as you can see, this is against the current. Take note, for the boat to be able to move against the current, the velocity of the boat should be greater than the velocity of the current. Otherwise, the boat will be taken by the river current. So we have, for this case, the equivalent of the relative velocity is the velocity of the boat minus, since opposite direction, the velocity of the current is equal to distance over the time. But what is the total time if it is against the current? The total time is 3 times t. So we having, what is the velocity of the boat? We have 40 miles per hour minus velocity of the current equal to the distance over 3 times the time. So we having the equivalent of the distance S is equal to 3 times t multiplied by, we have 40 minus the velocity of the current. How about for this case, if we have the same direction? The relative velocity is equal to the velocity of the boat plus the velocity of the current equal to the distance. What is the time? Okay, a single value of t. So this is t. We have velocity of the boat. This is 40 plus velocity of the current equal to distance over time, or the distance is equal to time multiplied by 40 plus velocity of the current. So we have two equations for distance. S equal to 3t, 40 minus bc for this case. S is equal to t multiplied by 40 plus bc for this case. So let us equate. This is 3 times the time multiplied by 40 minus bc equal to the time multiplied by 40 plus bc. So we may cancel the time. So let us compute for the velocity of the current. So this is the same as 3 times 40 minus the velocity of the current is equal to 40 plus the velocity of the current. And we have this, and this is 20 miles per hour. So again, for the boat, be able to move against the river current, it should be greater than the velocity of the current. As you can see, we have 40, so the answer should be less than 40. So it's 20 miles per hour. On our choices, we have letter, that is letter C. Okay, so our next example is also a passport exam way back 2010. So an airplane can fly from A to B along with the wind, so the same direction, the plane and the wind, for 1.5 hours, a distance of 500 kilometers, and if it is against the wind, 1.6 hours. So 1.6 hours implying the same distance, 500 kilometers against the wind. What is the velocity of the plane in still air? So our first case, that is the same as the same direction, velocity of the plane plus velocity of the wind is equal to the distance over time. What is our distance? We have 500 kilometers per hour divided by the given time. This is 1.5. That is our first situation. Second situation, we have the velocity of the plane. Take note, that is velocity of the wind minus, since they are opposite in direction, velocity of the wind, the same distance, 500 kilometers per hour, but the time this time is 1.6. Again, take note that the velocity of the plane should be greater than the velocity of the wind, okay? So that the plane can move against the wind. Two equations to unknowns. Let us solve for those values. So using Canon F-789 SGA, we have mode equation, that is mode number 5, number 1. So we have 1, 1, 5, 5. So we have the velocity of the plane. Okay, velocity of the plane is equal to 322.92 kilometers per hour. Then the velocity of the wind is equal to 10.417 kilometers per hour. So our answer is 322.92 kilometers per hour. That is the velocity of the plane. So in our choices, we have 322.92. Okay, closest value 323 kilometers per hour. Letter B. Okay, so let us consider this is a particle moving over a circular path. So let's say we have omega. This is the angular velocity. Then we have alpha. That will be our angular acceleration. And let's say theta will be our angular displacement. So for the cases that we will be having, let's say constant angular acceleration, or let's say constant alpha, we'll be using the same formula. We are just using these new variables. For example, we have the final angular velocity squared is equal to the initial angular velocity squared plus twice of the angular acceleration times the angular displacement. We have the final angular velocity is equal to the initial angular velocity plus alpha times the time. Angular displacement is equal to the initial angular velocity times time plus 1/2 of alpha the time squared. So we are using the same formula as before. Okay, so what are the new things that we are going to consider for rotational motion? If we are to consider other factors, I will be having the terms. Let's say this is the centrifugal force and the centripetal force. So centrifugal force, that is the outward force acting on a body moving along a curved path. So the equivalent of the centrifugal force is basically equal to the weight of the object divided by the acceleration due to gravity, the tangential velocity squared divided by the radius, or the radius of the circular curve. So we have b sub t is equal to the tangential velocity So what is the equivalent of the tangential velocity? This is equal to the angular velocity multiplied by the radius. Then, how to compute for, what is the equivalent of this term? Okay, we have the tangential velocity squared over the radius. So that is the same as the normal acceleration of the body moving along curved path is equal to the tangential velocity squared divided by the radius. So this is the same as normal acceleration. We have angular velocity times the radius squared divided by r. This is the same as omega squared times the radius. So if this is an acceleration, what is the equivalent of weight over the acceleration due to gravity? Basically, mass is equal to the weight divided by the acceleration due to gravity. So we have the centrifugal force is basically equal to what is weight over the acceleration due to gravity? That is mass. This term is the normal acceleration. Basically, from the second law of motion by Newton, the force is equal to mass times acceleration. So we'll be having the equivalent of the tangential acceleration. Okay, so tangential acceleration, that is the same as your angular acceleration alpha times the radius. So if you are to compute for the total acceleration is equal to, that is the square root of the resultant of the normal acceleration. This is a sub n squared plus the tangential acceleration squared. Okay? So these are the terms to be considered if we are dealing with a body in a circular motion or moving over a curved path. So let's have an example. Okay, so let's have our example for the rotational motion. Sabi dito, The angular speed of a flywheel having a diameter of 6 meters is 20 RPM. So that is our initial angular velocity. We have 20 RPM or 20 revolutions per minute. I find the tangential velocity at a point at the edge of the flywheel. So the diameter of that wheel, we have a diameter equal to 6 meters. So we are looking for, we have an angular velocity. We are looking for the tangential velocity. Let's say this is the base of t. So obviously our radius is equal to 3 meters. All we have to do is express 20 RPM to radian per second. This is multiplied by, we have 1 revolution is to 2 pi radians. This is multiplied by, we have 1 minute is to 60 seconds. So we can cancel the revolution and a minute. Remaining unit will be radian per second. We have 20 times 2 is 40 pi over 60. We have, that is the same as 2 over 3 of pi. This is now in terms of the radian per second. How to compute for the tangential velocity? Tangential velocity is equal to angular velocity times the radius. So we have a tangential velocity is equal to omega, that is 2 pi over 3. This is a radian per second, that is multiplied by the radius. We have a radius of 3 meters. Take note, radian is the same as unitless. It will add up the unit of the multiplier. So we have tangential velocity is now equal to, that is the same as 2 pi meters per second. So what is the equivalent of 2 pi in decimal? This is equal to 6 point. This is the same as 6.28 meters per second. Equivalent tangential velocity of the 20 revolutions per minute. So you have letter, this is letter C. And so this is our next example. So a 2 Newton weight is swung in a vertical circle of radius 1 meter at the end of the cable that will break if the tension exceeds 500 newtons. Find the angular velocity of the weight when the cable breaks. So for example, we have this 2 Newton weight. It is attached to a 1 meter cord or cable, then swung on a vertical circle. All we have to do is we need to pinpoint on what specific position of the weight is the cable critical, or the tension of the cable is maximum. That is on the lowest point. If the object is at the lowest point of the vertical circle, the tension is maximum. If we are to cut that or separate this portion, what are the forces that are we going to consider on this example? So the tension will prevent the object from, the tension will prevent the object from moving out from the circular motion. That is our tension. So what is the direction of weight? The direction of the weight is always downward. Then other than that, other than the weight and other than the tension, we are to consider the centrifugal force, since that is a circular motion. What is the direction of the centrifugal force? Centrifugal force is always away from the center. Its direction is always away from the center. So we assume that the centrifugal force is also downward. So that's why if the object is on the lowest portion of the circle, the tension is maximum. So by summation of forces, vertical equal to 0, upward forces to be positive, the tension is now equal to the centrifugal force plus the weight. What is the limitation of the tension? We have 500 equal to the centrifugal force plus the weight of the object. We have 2 newtons. Equivalent of the centrifugal force is equal to 498 newtons. Okay, so what is the equivalent of centrifugal force? A while ago. We discussed the equivalent of CF a while ago. That is the weight divided by the acceleration due to gravity, tangential velocity squared divided by the radius. But we can simplify this one as the weight over g. What is the equivalent of tangential velocity? That is the angular velocity times the radius squared divided by the radius. So we have centrifugal force is the same as the weight divided by g. That is omega squared times the radius. If you have to cancel one of the radius. What is the value of the centrifugal force? We have 498 newtons. Equal to, what is the weight of the object? That is 2 newtons divided by 9.81. So if this is multiplied by the angular velocity squared, what is our radius? We have 1 meter. We can now compute for the angular velocity. So that is the same as 498 times 9.81. That is divided by 2. Then square root. So we have, this is the same as 49.424 radian per second. But in our choices, the required unit should be in revolutions per minute. So we have the angular velocity is equal to 49.424. This is radian per second. Okay, multiplied by, we have 60 minutes, 60 seconds is to 1 minute. Then multiplied by 1 revolution is to 2 pi radians. So we have the angular velocity, this time in terms of the revolutions per minute or the RPM. So we have 49.424 multiplied by 60, this is divided by 2 pi. So we have 471, this is 471.964 revolutions per minute. That will be our answer. So let's check on our choices. 471.964. Closest value is 472. Letter C. Okay, so our next example, this is a horizontal circle from our previous example, which is a vertical circle. So a 10 kilogram mass hangs on a 4-meter string. If it is rotating on a horizontal circle at a constant rate of 0.5 revolution per second, find the tension in the string. Okay, so this is the motion is also called the conical pendulum since it forms an imaginary cone. So we are looking for the tension on the spring. So let us first do our free body diagram. We know that weight is always downward, and the centrifugal force this time is horizontal. It is always away from the center of the circular motion. And this is the tension. Let's say this is T. So if we are to form let's say, since we have only 3 forces, we can form the force triangle. We have weight is downward, the centrifugal force is horizontal, and the resultant, that is the tension on the string. So the problem is, we don't know the height of this conical pendulum. The radius of the circular motion is also not given. So if we are to form the triangle for these dimensions, okay, we have the 4-meter string. We don't know the radius, it is not given. We don't know the height. Okay, so how do we compute for the tension? Since we cannot, we don't have an angle, or yes, we don't have the angle to compute so that we can use either sine or cosine. Okay, so we can first consider the centrifugal force. Why centrifugal force? Since we have an angular velocity. Let us use this angular velocity. As you can see, this is 0.5 revolution per second. We need it in radian per second. Angular velocity of 0.5 revolution per second. This is multiplied by 2 pi rad is to 1 revolution, since this is already seconds. We have the angular velocity, 0.5 of 2 pi is pi. This is pi radian per second. So we are considering centrifugal force. For example, supposedly we have a theta here. That is, the cosine of theta should be equal to the centrifugal force to the tension. It's just we don't have theta. Okay, unlike if we are to consider on the other side, if we are to use the 4 meters, the cosine of theta is, this is the same as the theta, the radius is to the hypotenuse, we have 4 meters. So this is our two equations equivalent to cosine of theta. So we have cosine of theta is equal to the centrifugal force to the tension. That is also equal to the radius is to 4 meters. So what is the equivalent of the centrifugal force? That is equal to the weight divided by g, tangential velocity squared over r. But again, we have the centrifugal force. What is the equivalent of weight divided by acceleration due to gravity? That is the same as mass. Multiplied by angular velocity, radius squared divided by the radius. Another equivalent of centrifugal force is the mass, omega squared times the radius. Okay, that's the equivalent of centrifugal force. Then, okay, we are to use these two terms, or these terms. What is the equivalent of centrifugal force? We have mass. Centrifugal force is to tension equal to R is to 4. Okay, then we substitute equivalent of centrifugal force. We have mass, angular velocity squared, the radius divided by the tension is equal to R, the radius over 4. So we can now cancel the radius. That's why the radius is not given. Okay, then what is the equivalent of the tension? The tension now is equal to 4 times the mass, angular velocity squared. Our tension is 4. What is the mass? 10 kilograms. What is the angular velocity? We have pi. This is squared. So if we are to do unit analysis, this is 4 times 10 kilograms. This 4 is 4 meters. The mass is 10 kilograms. Then angular velocity is pi. That is pi radian per second. This quantity is squared. So we'll be having a unit of, what will be the unit? Okay, radian is the same as unitless. This is kilogram meter per second squared, or the same as newtons. So let us compute for that value. That is the same as 4 times 10 times pi squared. So we have 394.784. 394.784 newtons. Let's check on our choices. And we have letter A, that is 394.78.